So, today we were talking about how to build and deploy application just using Kubernetes. Okay, so can I see the hands to who is more or less related to what is Kubernetes so far? Yeah, it's something that is not new. It's quite old actually. And what we were doing today. So this, I prepared a couple of examples. One example is actually just a Spring application, nothing with nothing inside. It's just a Spring application that can start and have only installed actuator. So because I need the provenness proof and also I need the liveness proof for Kubernetes. But you can check this example here from this QR, and we were using just Kubernetes, and of course, so we need to host the code in some place. So we were using GitHub for that. Cool. And you can get also my contact from ST Energia, and you can write me or whatever if you want to talk something after this meeting, or we can see each other after the talk as well. So for the future, you can get it from there. What we will be seeing today. So we will be talking about ArgoCD. I think that probably most of you are also know what is ArgoCD. And we were talking also about what is Argo Flow. But the thing that is for me most interesting is about Argo Events. So we will go all these three topics, and then at the end we will be able to build our application just using Kubernetes. So the idea for me for that was that currently when we want to build an application, we usually use some tools like Jenkins or like Bamboo or whatever other stuff, and this is external to our cluster. So actually, we need this external tool, that we need maintenance, that we need even to some resources for this external tool, and I was thinking how, because everybody, when I was starting with the ArgoCD stacks, so everybody was talking about ArgoCD. So how ArgoCD you can implement these GitOps. So what is GitOps? No? Because at the end, probably you are also related what is GitOps, correct? Can you raise the hands? What is GitOps more or less related? So not many of you. So I would say that the GitOps is some kind of configuration as code. So we have a repository, okay? And in this, instead of, if we want to handle our cluster, we don't need to go like kubectl, or we don't need to use Rancher to actually set up what is when we want to deploy it. We don't want to set up how we will scale, nothing of that. So instead of that, we can have a repository when will be the single source of truth, and when will we put all this configuration for Kubernetes. So if we change it in the repository, then in this case, ArgoCD need to make need to make that the state that we have in our repository is the same state that we have in our cluster. Okay? And in the other way around, if someone go to the cluster directly and try using the kubectl, Rancher, or whatever, they try to change the status of our cluster. So the cluster need to be aware of that and prevent it. No, I don't want that, because my real estate is in this use repository. So this is the idea for GitOps, and ArgoCD is just one of the tools that implemented. So, and more or less, this is what we will see here. And let's start with this. I will say that we have these two repositories. I will show you two of these applications. One application is this. We will present everything based in my, I am using my own cluster, so local cluster. In this case, yeah?
Can you zoom? Can you zoom in a bit? Yeah. Thank you.
Don't know?
Yes, awesome. Thank you.
Cool. So, let's start from here. So, I say, everything is installed. I use a Docker desktop, and I just installed there ArgoCD, Argo Workflow, and Argo Event. Okay? So this is the only tool that I actually install in the cluster, nothing else. So to start with ArgoCD, so the main object that ArgoCD used to manage the status of, to provide this GitOps approach is this application. So the application is when we are saying to the ArgoCD, okay, the status of my cluster will be in this repository. I created two different repositories. I created one repository for the GitOps, when we will have all these objects, all these Kubernetes objects, all the manifests, and I created a different repository for the application, okay? So if we start from there, you know, the API version kind, this is like always the same. Then we have some metadata when we want to, what is the name that we want to give to the application that we want deployed in the cluster? What will be, in which namespace I will deploy this application, and what kind of project will be the file. Then we have the source. The source is when we will say to ArgoCD, okay, the manifest for this application will be stored in this repository. So if you can see, this is just the normal Git repository. We have the tiger version. So, and what point in this repository will be the real status for the application? I say head. So is the reference to the head of the repository. And in which path we will have this manifest. So I create a folder that is called QAS when we have the manifest for the application. So how I will deploy this in my own cluster. So in the same cluster, when ArgoCD is running, we can set the same server. So the same server is like, you can set the same Kubernetes default.cfv. And the namespace that I want to create is pet store production. And I will say to ArgoCD, if the namespace doesn't exist, please create it for me. This is why this option give here. That, okay, if the namespace doesn't exist, you create one, and then we have that I want everything to be automated. I don't want any human intervention to actually change the cluster status. And I put two of these options. One is self-health. So that means if someone makes some change directly in the cluster, the ArgoCD will prevent that happens. So it will sync again the status with the one that we have in the repository, and the second one is prune. So that means if someone remove this application from ArgoCD, all the objects that depend from this application will be also removed. Okay, we don't need to do nothing. If we don't want the application anymore, we just remove the application name, the application from the cluster, and Argo will remove all the dependent objects. Let's see how this works. So you can apply this in any way that the usual way that we apply everything in Kubernetes. For example, we can go for what is the name? Pet. I will put this a little bit bigger. I cannot see what I'm doing. Okay. The application, I call it pet store. So, and you can apply the configuration like this. So it's simple. You use the same qctl, apply the file, everything, and you apply it. So of course I already applied before the speech. So any change, and we can go to a cluster. So in the cluster we can find. Let me 1 second to actually get a new token for the cluster. So we have the pet store namespace, and we can have that we see here a deployment. And if we go, we can change the deployment. Let's say that how many pods. We can also go here and see that we have this image, and we want 4 replicas from this image. Okay, so all of this was applied directly by ArgoCD. And let's say that I want to change the status of the cluster manually. So instead of 5 replicas, I want to replace it by 2. And some point, so I will write 2 here, and I want to update it. So let's refresh. Sometimes the dashboard doesn't. So if you see, we cannot actually. It was not able to do it. So it never will. Change it, because I say that you need to be in sync with whatever we have in the repository. And in the repository we have that you have 4 replicas. But what happens if I change the things in the repository? For example, let's say that we are now going to our repo. This is when we have the status of the application, and instead of 3 or 4 replicas, I want only 2. And I want to change also the image. So I have the image 6. Let me check in my registry. I have other image. I will say that we will use this release instead. So, and I will put this version. I will save. And I will push this to the repository. So I change my iPhone. I change here. Stage. I will put some okay. I will save and we push it. So now the new status is in the repo. In theory, ArgoCD should read this status. It will take at least 3 minutes. So in the worst case, 3 minutes, because this is by the default how many on the time that he update the repository. So change the status if something changed. So and we will have here that now we have this comment that if you check it was the previous comment in the repo, and it will see. You see now he detected. You were able to see it, that he detected that something changed, and now it's progressing. So he said that the sync status, okay, will be this one, update image status and replicas, but the actual one is scaled to 4. So he already get it. He said, okay, something changed in the repository, so I need to start changes there as well the application. So if you see, he's trying to remove the old pods, it creating the new ones based in the new image. So I didn't make any change in the cluster. I just made the change in the manifest in the repository. I just pushed it. Cool. So that means that my cluster will be always have the single source of truth. That will be my GitOps repository, for example. So let's wait until it finishes. So he already deployed 1 pod. If you can see, let's see. It is also removing the extra pod that we don't need anymore. And we can check the new status of this pod, for example. Let's go here. Let's see the details. And if we go to the image, so now we see that the image have a different image actually. So this is another thing. You can check your objects from Kubernetes cluster using ArgoCD. So the same UI, you don't need actually this dashboard anymore. In any way, I have it in case that I show to you that it's the same thing than in the cluster that we are showing in ArgoCD. And also the replicas will be different, will be less than before. Okay, let's go to the dashboard here. You see 2 pod of 2, because I said 2, and if we update here the manifest, we have now the new version, and we can see the replicas are 2 now. So I didn't apply any change, just was ArgoCD by itself. Cool. So far so good. For me was nice to have this, to see this with ArgoCD, but in any way I didn't find it. How useful is this? No, because okay, we have a single source of truth. I will always know what will be the status of my cluster, but I don't want to, every time that they change something, I don't want to go to the repository. I don't want to update the manifest. I don't want to push it to Git. So because it's too much work for me. So I don't. I was thinking, okay, something is missing. So then we can. Then I found this cluster, this Argo Workflow. So what is Argo Workflow? If you have any question in between, you can do it as well. So for me, it's not any problem. So what is Argo Workflow? So Argo Workflow is no more than that you can build pipelines in your clusters. So, and these pipelines can execute different actions. And every action, you can use a different image. So you can use different containers. And this is something different from Argo that others, the other services that provide the same thing, the same workflows in Kubernetes. That usually other solution create a pod and then deploy every these actions in different containers inside the pod. But in case of ArgoCD, Argo Workflow, it is not doing that thing. So it is creating different pods, and inside this pod, then it executes every task. So they have pros and cons as well, but one of the cons that we can say is that they need to share. So what happens when you need to share different volumes between different pods? Okay, that maybe could be one of the withdrawal, but they have many other stuff. So you can control the memory better, you can manage better your pod than your container inside the pod. So this is one of the stuff. And how it will work. So let's say we will have one Kubernetes manifest, our configuration in our YAML. So we will push this to Argo. Argo, I want to execute this task. And Argo will orchestrate all the pod that it needs to actually fulfill the task that you write in this manifest. Okay? So compare it with other tools. Let's say we are using now Jenkins. What happens if I want to build pipelines that for, let's say, several teams, that we will have more or less the same deployments? So in Jenkins, we need to build a Jenkins library. And for build a Jenkins library, we need to know Groovy, for example. And we need to create a repository. We need to build this Jenkins library. And in some point, will may not build generic enough. So we need to build another extension and so far and so on. So, and we need to maintain it, all this stuff. So in this case, what is the thing that I like for Argo Workflow? So that all of this will be just Kubernetes manifest. So we don't need to know anything specific. We just need to know how to configure the manifest. We can share it between them. So we will see what is this. So we can share every steps in for different workflows in our cluster. It's a super simple way. We can use any of the standard or official images to do all of this. So let's see how works, how looks a manifest of Argo Workflow. So here I have this one. I already prepared. Let's see if we can you see there? So it's the same, more or less the same version, the EP version, you have the same it's workflow. This will not change. So, but we have a metadata. And in the metadata, we have a generated name. So we can use both of those two things. We can use name as always, but also we can use generated name. So what is the good things? What is the advantages if we use a generated name. So that ArgoCD, but instead it will complete it with some hash at the end. So we don't have two different pods with the same name. So it will we are creating the prefix, just the prefix, and Argo Workflow at some point it will create some hash at the end, and you will not have collision between your pod names. So this is what is recommended to use it. And then we have an entry point. We will talk about this a little bit later. And then we have volume. So how we pass the things between one pod and another. So we need to use volume, nothing new. We don't have this kind of problem in Jenkins, for example, because every time that we create a new job, Jenkins create a workspace for your job, and then you have and you don't need to be careful. Okay, what happened between this action, between this agent and this agent? Everything we will be mounted in the same workspace, so no problem. But now we need to take care of this. So we need to put volumes, and in these volumes, what I have. So I put a Kaniko secret. This is one of the things that we were talking about as well. We have Kaniko secret. It's a secret that only contains access to my registry in Docker Hub. So this is the place when I want to store my images. So I will build my image and I will store it in my Docker Hub. You can use anything you want. I use a Docker Hub, but you can use Nexus, whatever you want to use. And then I want to create some volume as well, a volume to store files. And this is why I'm using volume claim templates. So I want to create a volume, and I will put it like report dir, that's a reference. And this is where I will store my project, so the Git repository. And then we have this template. This template actually is where the actions are. So in the simple way, we have one step per action that we want to execute in our pipelines. These two dash in the front means that these actions will be executed in parallel. We can also have actions that you don't want to execute in parallel. You want to execute it. Sorry, these two actions will be executed one after other, not in parallel, if not in sequence. So if you want to execute actions in parallel, so you actually need to create only one dash. Okay. If you have two dash, will be in sequence. If you have only one dash in the right, that means that this action can be executed in parallel with the previous action. Cool. This is one way to do it. Argo Workflow also provides a different way to approach the same thing. But let's do it in this. Let's check it in this way. So I have these actions here, and we have a template. Okay. So this template is gclone. If we go a little bit back down, we saw that we have these templates as well here. So what is gclone? So gclone, I say that will be running in a container, and the container we use the image Bitnami in Git. Okay, so it's an image for Bitnami, and it will execute the command git clone. Okay, and what argument? So the argument that I actually pass it as an input. Here we set the input, we have a parameters, and we say that the name of the parameter is repo, and we can reference it using this sentence here. So this mustache curly bracket. So and we can take, and the second parameter is when I want to store my repository. In this case, I will put it in the volume because I will mount the volume that I said before. This is a repo dir. The one that we set it in the top, I will mount it actually in this repository. And the good thing, as I mentioned, you can constrain how many resources you want to use. Okay, so it's just to clone the repository. We don't need a lot of memory. We don't need a lot of processing for that. So I will create a pod that have only access to 32 megabytes of memory and 100 piece of CPU. Okay, so something simple. Then, after this finished, what do we do? So, as you see here, I said in the template, I say the name, and I want to set the argument for this template. We already said that we will create. We have parameters that the name is repo. I will put the clone address of my repository in a way that he knows from created, and I can use it for different repositories. So I can use the same template, and I just need to update the repository name, and that can use for any repository in Git. So then I will run the test. What is, we have the template as well, Java JDK 17. So the same, we have a template that is Java JDK 17. And in this case, we are using Eclipse Memory. And I want to execute the chill command. And the command will be just go into the volume, into this address, because I will mount the same volume. So I have a volume, correct? I clone the repository. This pod is destroyed, the volume remained, and now I will mount the volume, the same volume, in different pods. I already have the repository there, correct? Cool? So now I will execute just a test from Gradle. Using the Gradle RAPL, I want to execute tests. Okay, to be sure that all the unit tests for this application is running correctly, and then I want to do another stuff. So, correct? So, first step, I clone the repository, the pod was destroyed, the repository remained in the volume, and now I want to run the test over this repository. Another pod, another image. So, this is something more, did more work, okay? So we need to, if someone is related with the Spring Boot, when you made the test and the repository sent it started downloading all the dependencies, correct? So it needs a lot of memory. To go to the network, download all the dependencies that I needed for test. So in this case, I need a little bit more of RAM, a little bit more of memory. If you can put less, okay, that will take 10 minutes, okay? If you put, I put a little bit more in order to do it like in a time that we don't get a sleep here. But yeah, the same. So I mounted the same volume in this address, in the address that I set here in the argument of the repository. So let's say that now we already cloned our repository. We already run the test over this repository. The next step is build the image, correct? So. And I don't want to use nothing else, so I want to do it only in Kubernetes. Have you tried to install Docker on Docker? You know, because you need Docker, okay? So you want to build an image, you need Docker. You need to say Docker build, correct, no? And you know, this is a Docker on Docker, and then Docker on Docker on Docker, okay? So we never end. So the thing is that it's not really recommended to install Docker on Docker. Even if you try it, it will have some problem with your daemon and the stuff. But for that, we have an option. Now we have Kaniko. So Kaniko is an image that allows us to build Docker images on Kubernetes. Okay? So this is the next template. So build Kaniko. I use in the debug mode because I want to see what is happening inside, but actually you can use not the debug mode. So in your case, you can use the official image. So, and the Kaniko, the command is just Kaniko executor, and I will pass the context. So the context, what is my repo? This is just a really simple example how to build an image using Kaniko. You can put the context, have a lot of options, correct? So you don't need to, this is just a simple example. And the destination, what will be? So the destination, I want to put it in this registry with this tag. So nothing fancy. And of course, I need access. So remember that I set the volumes for my Docker hub. Okay? So they need access to my Docker hub. So I save this in a secret, and Kaniko will use it. So if we go a little bit up, we can see that we want to get it from this repository. I want to store it in this domain in my Docker hub, and I want to the Docker the tag it will be 8. So, but let's put 9 now. So if we go to my Docker hub, so now we are here. If we refresh, we can see that my last image is actually 8, and I want to build 9. All right. So let's try to find the right terminal. Let's say this Argo. So in this case, instead of use kubectl, I will use Argo command, because it will provide this watch that I can see what is happening inside Argo from my terminal. So because you can put it using kubectl, it's a different configuration, but Argo provides this kind of extra features. How to do it? So I will go. And you see that something happens. Start. We can also go to the Argo Workflow. We can go to the workflow, and we see that something starts here as well. So, but here you can follow also in the terminal, or from here. So Argo is just starting something else. It creates the clone. You see, the first thing happens. So this is one pod executing one action. Clone the repository. So now it continue with another. So I will run the test over this repository. Let's see if this magic happens, that it saves the repository in the volume, and then it will start running the test over this repository. We can also follow from here all the what is happening inside the pod. We can have logs. And we see what happens. So if you are a little bit related with the Spring application, this is just a standard Spring output when it's building something. And you can check it from here as well. So what is happening? But of course, this is in your cluster. So that means that if you have a write collector, this sending into Elastic, for example, and you can check it as well in Grafana. So all of this could be connected at some point. This is the things that I really like. So everything could be seen from Grafana as well, because you are collecting all these logs, and you are sending source RSA to Elastic, and you are getting from Grafana. You can see also have your board, so your CI/CD all together. Because what happened for us in some point that we have the CI/CD, okay, we can see the things in Jenkins, we can see the things in the cluster when are deployed, but what happens if I want to have all in one? So I need to install a lot of Fluent in Grafana, to actually see what is happening in all my deployment, what is the status of my cluster all together. So now everything in the cluster is the same collector, sending the logs for the same place, and you can show it in the same tool. So it is running. Let's say that I don't have any bugs. Because I don't have any code. So it's the best way to don't have bugs. I didn't put any code inside this application. So I'm quite sure that it will pass. And then it will start building with Kaniko. And let's see as well. Okay, we can see also that it's a pod, the face is running. You will see at the beginning also it's yellow. This is starting from the pre-containers to preparing the task. We are almost there. Okay, we can show something else. Okay, so let's move. I can show something else. Okay, but so far we were talking that we can share this workflow between several teams or several projects or whatever. In the way that I show it to you, actually it's not possible because we have only one file, and in this file we have all the templates and we have all the workflow. So how I can share this between different projects, let's say. So if we go here, we can see that also we have the workflow provide the way that we can build just templates, and this template is like cluster workflow templates. Correct? So we have this cluster workflow templates that we can create for only one steps in the pipeline. So let's check this first one. This is a image. So this one is just to Kaniko, and in this one I put the same. So I will need to have a volume that will be the Kaniko secret. I said it's actually my when you have your hop, your registry, and you have also parameters. Cool. And the same thing for git clone, for example. I put the same. So I took the template. In this case, I make it like a cluster workflow template. The metadata is the name that you were using, the template git clone. So the same with the parameters and the stuff. In the Java, I make something a little bit better. Instead of put the parameters there, I put what I want to execute. I put actually the parameters. So in a way that you can run first test, unit test, for example, but then you want to run the integration test, or you want to run the whatever other test, or whatever you want. So any command that you want to execute inside a Java. Okay? So you can use it for any one that you want. And then I created a final one. So I say at the beginning, I don't want to, every time that I create some change that I want to update my cluster, I don't want to go to the repository, change the manifest, create the commit, and push it. So instead of that, I create a template here, and I use Git as well, not latest anymore. I choose a specific version of Git. That is because we already know that use the word latest in our manifest is not a good idea. And I just will execute this script. So the script is, okay, I will clone the repository. I will go in this repository. I will print out the original manifest just in order to have it in the logs, what it was the original one. I will find the place that I want to change the new, when is the image tag and the image name, and I will replace it with the new one. All of this I set it as parameters here, and then I will just create a commit and push it. So this is the thing. I will not need to actually go and update my image or anything else in my repository. So I don't want to do it. I want someone to do it for me. And this is one of the templates okay, cool. We already run everything. It was built, and if we go to my Docker Hub, so I have the new tag here. Cool. So my image was building also using Kubernetes. I don't have a Docker or anything else there. So and my template will stay a little bit simple when I do it in that way, no? So because I can put and this is another way to do it as well. I don't have, so we can have steps, but also we can have DAGs. Okay, DAG is like it's a graph, directed graph thing. So and the difference is that we can have dependencies in our task. So that means that this task run unit test will run only when clone repo task is run. So and workflow, but instead we create this graph and we represent it to you. In this case, we don't have a graph; it will be the same, one after another. But I just want to show you that you can do these things as well, and you can also manage the flow. They say if this action return this output, I want to do the step 1 and not the step 2. Correct? So let's say that we already want to deploy, want to build an image, but the image is already built, already exists. You can have an previous steps that you check that okay, is in my hop already exists an image with this tag. Okay, I will not build it. I will just retag it. with the new tag. So you can have the same image tagged as many times as you want. So this is something that we save time for you. And how we use it, for example, we deploy based in tag. We say that, okay, this tag, if I want to deploy something to dev, I put in the tag that the tag have the name, let's say, candidate. Okay, so this is something that is candidate to be released. And if I have the word candidate in my tag workflow by itself, we know that I want to deploy this to this cluster, to this test cluster. The tester can test whatever, and if everything is okay, I will tag it with the tag release. That means that I want to release it to live, to production. It's the same image, just that with a new tag. So I don't need to build, I don't need to run the test again. So I already know that it's an image that exists with this tag in this point, and I just tag it new. So I save time for this as well. So it's possible to do it as well here. We can do the same. But in this case, I think that I have 7.7. I already deployed 9. Let's say that we will deploy 10 and 10. So now we are going a little bit more there. So we don't only will deploy the image. So we not only will build it, we will deploy it actually. All right. So I will build the image. I will save it in my Docker hub, and I will update my GitHub repository in a way that it deploy the new image that I created in the cluster. Let's try to do it. Open a little bit more this because the same we should meet with Argo. And if we go to Argo, we should have a new flow. If you see, it's the same, it's the different name. This is store build from the templates, and then some hash at the end. So now it is building, but using the templates, and it should deploy it to my Kubernetes cluster. Let's see how it goes. So, but in any way, another question. How many of us want that every time that you deploy something, you need to go Argo CD, Argo, whatever, and you need to push this to Argo? How many of us we want that? Are we doing this? Okay. Are we doing this for us? No. Okay. So actually, we are using something else. So we want to, if I push something to my repository, correct? If I push something to there, I don't want to need to do nothing. So I open my pull request, someone review the pull request, someone accepted, and when you merge it, you want to everything start from there. So you don't want to then and go and apply Argo or whatever. So doesn't make sense. So for that, what we have? Well, so then we have Argo Event. So Argo Event. And Argo Event is the way that we can do that. And how Argo Event works. So Argo Event, you can define in your cluster sensors, and you can define your sensor and your cluster signals. So Argo Event can work with all these signals that could be a JIT, for example. They have a specific for JIT, for webhook, for example. I will show the sample in webhook right now, because a webhook is the most easy thing. It's just a HTTP request. Cool. So let me show you the example how this will work with Argo Events. We will keep running the Argo there, and let's say we have this webhook here. How we define it? It's the same. So we have Kubernetes manifest, The kind in this case will be event source. Okay, and we will define that I want a webhook that will be listening from this address. It will be the type. The method will be post. So we send a post, and I want to listen in this specific port. 12,000. Okay, 12,000 is not a really used port. Of course, in this point you will need to have some kind of ingresses. I didn't have an ingress. I just make the port forward. Okay, so from my port 12,000 to the port 12,000 of the cluster, because I didn't want to deal with all the stuff related with the ingresses. And now I can go to my any of my repositories here. I can go to settings. You can go to webhooks, and you can define your webhook here. Correct? So, and your repository, when someone merges a pull request, for example, it will send this pull request to your cluster. What happened? I am running in my local cluster, so my local GitHub cannot send any pull request to any request HTTP request to my cluster because it's locally in my computer. So what we will fake it a little bit. So instead of wait make a pull request or whatever merge it, I just will use Postman to create a request to my cluster, okay, and see if Argo Events will listen this thing. To try to do it as most similar possible to the real world, I just copy from GitHub what is the request that GitHub sends when you merge a pull request. So I copy this from there, and I just put my data there. And now that means that we have this port listening, but we need also a sensor that reacts over some events. So in Argo Event, we don't need only to define the webhooks, we also need to define the sensor. What will happen if I receive this event? So in this case, I defined this sensor. The sensor with using that tag created, that what was created before, and then you have the trigger. And the trigger, in this case, will be an Argo Workflow. So I will start an Argo Workflow. If I receive this event, I will start Argo Workflow. And in this case, we have the same thing, volume, everything, all the templates, all the stuff, but one different. You see, I put these values in empty string because I don't want I want to get the data from the request, correct? And I want to build it based in the data that I receive from the request. So you have this extra configuration in the bottom that you say, okay, this is the event that I received, and I want to get this data, body, repository, okay, this is the body, and then we have repository, and we have all the stuff. In normal way that we want to get the data from an object, and I want to put it in the specification, in the template 0, in tag 0, argument, parameters, or whatever.
Sorry, there's a small technical hiccup.
Okay, cool.
AI.
Yeah.
Hopefully it's going to get back shortly.
No. I don't know how to do it, but should. Yep. And this one, because okay. It's coming back. So cool. We have more now. So we are better than before. No. So if we go to the cluster here, so you can see here now, it's in stereo. Let's check a little bit. We have the image 10. If we go to the repository, we can check 1 second. Fast. Let's say our Kubernetes 5, the deployment, we have the tag 10, correct? And if we go to, you see it's progressing already, see? So, and it will move it to the right version. So, all of this is happening without any human intervention, or at least the less one. So, and let's say that here I want to create a new tag. We have the June, sorry. And so I will put the tag 2, and I will send this request, faking that I am the GitHub, okay? So I received a success. That means only that the cluster received the message. Doesn't mean if I don't have any sensor, even I will receive success. So I need to have a sensor to actually start doing something. I will go now to here and let's check if something starts. Argo event. So now we have here, and this is started by this Argo event. So by the webhook that I created. Let's see if something changed as well. And if you see here, you can go to the cluster template. This Argo Workflow, you can see all the things that we already done. We created all these templates. You can reuse it. We create an event flow, and you will see that we have a pet store merge that will be triggered to the webhook. This will trigger this Argo Workflow, and then with all the workflow that actually was triggered by that. So we can see all of them. Everything is, we don't know, okay, is this working? Okay, you can go here and see all the stuff. You can see all the event source, what is the type of the event source, and you can also see the sensors. So this UI is quite useful, I believe. Cool. So basically, we can wait a little bit until everything finishes, but I don't know if we have that time. And so I will show you later, but I will try to save some time. Any question or thing, everything works fine. So, any question? I don't know if we...
Let's try to squeeze in a couple questions, exactly 2, to be precise. So make sure they're
Cool.
I have a general one.
Sir?
General question.
Yeah, okay.
If there is an info to build a secure application, you want to use, and Kubernetes is seen as an option, is it secure by design, or we should take extra steps to make it more secure? What do you think?
So actually, by design, it's not super secure because you need to use your service account for all this stuff. You know, for example, one of the things that I need to do in this case, I need to modify a little bit the service account for Webflow in order that actually reach the cluster templates. So it could be secure, but you need to actually configure the service account in the way and the cluster roles in the way that is secure. By default, it's not. So it provides the mechanism to actually do it, but not by default.
Maybe a somewhat rhetorical question, but I used to build apps like you do JavaC to compile, Java to run the tests, and then jar to package it, and then it's ready. So here, this is like the complete opposite of having hundreds of YAML lines and other stuff. So where did we go wrong there?
So so can't go wrong. Actually, if we look the Docker file that I created for this application, let me try to show you. So here we have something similar that what you mentioned. Let me go here. So here we have 2 of the steps that you mentioned. So we have build, you know. So we are building this with the Alpine JDK, and then we package using bootjar. And then we copy this to actually we don't need JDK anymore to run the application, so actually we put it in a different image that is just JDR. But the thing that I'm doing here, I am skipping the test, okay? Because I am saying, okay, in my pipelines, I want to do it in the pipelines, not in the building the image itself. So.
Thank you.
Okay. So, but we can see anything else later. Okay, cool.
Maybe another reason for this kind of level of complexity is bear in mind that the STNRG is quite a sizey organization, right? And imagine your test suite takes hours to run, right? And in order to split the thing is what Oscar has also demonstrated, that you put the code base into a volume and then you spin up a number of containers to run off the same volume, the same code base, and parallel your test execution. Of course, if the entire test suite can finish while you make a coffee or do a stretch, right? Then you're absolutely correct. No reason for such complexity. But the bigger organization, the bigger the code base, the more teams there are.
Actually, we try to do the things most standard as we can. So if we build these templates, other teams that probably were using Java application with the Spring and whatever, they don't need to rebuild it. They just need to use the template that already exists. So this is the idea, to distribute it, the same process for everyone.
But when you need to debug it, then
yeah, when you need to debug it, then you need to go to the logs and all. But how everything is actually debug it is not that hard, because how everything is based in Docker, you can debug it in your computer. So you can put Docker run the image that is using in your container, and then you can see inside what is happening step by steps. So this is how I do it, or you can put a sidecar in your cluster and see what is happening from there. Different techniques to debug in Kubernetes, actually.
All right, so you can ask Oscar more questions during the break, which is happening in a few seconds. Oscar, thank you so much.
Thank you.
This is a presenter from DEVCLUB.
Thank you.